Okay, so now we are going to talk about this specific kind of word problem. Let's first read the problem and then I'll make a few comments. So it says a boat travels at 25 kilometers per hour in still water. We want to do a round trip between two towns along a river bank separated by 60 kilometers. The river is flowing at 5 kilometers per hour. The first question is how long would it take for the entire round trip? And the second is what would be the average speed for our round trip? Right. So in these types of problems, the first or the naive intuition usually goes as follows. So I want to go once along the river, along the flow of the river, and once against the flow of the river. So the speed, if I were going along the flow of the river, would be the sum of the two speeds of the boat plus the river. And if I'm going against the flow, then it would be the difference of the two speeds. So the average speed naively should be just the speed of the boat, because once it is getting assisted by the river and once it is getting opposed by the river, so the net effect should cancel each other. We'll see, and it turns out that it doesn't exactly work like that, but I think this is a good illustration of why it doesn't work like that. So yeah, so sometimes our intuition can fail us in these types of examples and we need to actually go through the numbers. So let's do this more carefully now. Right. So we have. Well, I'm just going to draw a picture so that the problem is clear to everyone. So this is a river. This is flowing at 5 kilometers per hour, and there is a town A. Let's call it town A, and there is a town B downstream. It doesn't matter which one is upstream and which one is downstream, but for concreteness, I'm just doing it this way. And I have a boat. So there is a boat, sailboat, let's say. This boat can travel from point A to point B and go from point B to point A at so its speed in still water is 25 kilometers per hour. So I need to find out what is its speed downstream and speed upstream. So for let's see. So speed in still water, this is just given, is 25 kilometers per hour. So speed downstream would be equal to the speed in still water plus speed of water, because the water is pushing the river, the water is pushing the boat, and the boat has its own speed relative to still water. It's just a simple addition of the speeds, which in this case would be 25 plus 5 kilometers per hour, which is 30 kilometers per hour. Let me just pull this up. Similarly, speed upstream, let's give this a name. So I'm going to call it V downstream, and speed upstream is equal to, using the same logic, it will be 25 minus 5 kilometers per hour, because you are trying to go against the flow of the river. So the water is pushing you back literally at a speed of 5 kilometers per hour, but your own speed is 25 in still water. So your speed upstream would be 20 kilometers per hour. Let's give it a name. This is the V. I'm using V for velocity, but we can also use another letter. This is the speed upstream, or I'm calling it VU. So now we have all the ingredients, and we know that the distance between the two towns, this is 60 kilometers. Okay, so now we have all the ingredients ready for our recipe. So what do we know? So the total time it takes, total time is equal to time from A to B plus time B to A, which is equal to, time is distance divided by speed. So this is distance AB divided by speed downstream, which is VD, plus distance from B to A, which is, I'm writing it this way, but the distance is the same, divided by speed upstream, which is 60 kilometers divided by 30 kilometers per hour, plus 60 kilometers, again distance from A to B does not change, let's keep the units, I agree, divided by 30 kilometers per hour, divided by 20 kilometers per hour now, which is 60 divided by 30 is 2 hours, plus 60 divided by 20 is 3 hours, which is 5 hours. So the total time it takes, this happens to be 5 hours. And the second part of this problem is also straightforward, given that we have done the basic calculations so far, is what would be the average speed for our round trip. So average speed for the round trip is equal to total distance divided by total time, which is, in this case, total distance is 60 downstream plus 60 upstream, which is 120 kilometers, and divided by total time, as we calculated in the first step, is 5 hours. This is 24 kilometers per hour. Let's just write this for completeness. This is 24 kilometers per hour. So as we can see, so if we are going downstream and then coming back upstream, then we don't get to simply take the average of the down speed stream and the upstream speed. We have to be careful here. If we were to take the average of the two speeds, then it would have been 25, because that's the average of 25 and 30. But it doesn't work like that. It is actually 24 kilometers per hour. It is slightly less. And the intuitive reason why this should happen, or why this is expected, is that so you are covering the same distance, once with a higher speed and once with a lower speed. But when you are traveling with the lower speed, you are traveling the same distance. You are not traveling for the same amount of time. So it's that you are traveling slower and you are spending more time to cover the same distance. So it's actually the geometric, it's actually the harmonic mean of the two speeds. This is a slightly more advanced concept, but it's not just the arithmetic average, it's what is called the harmonic average of the two speeds. So the average speed is not equal to the original speed of the boat in still water, and it is slightly less than that. It is always going to be less. Try to convince yourself. And so, for example, what happens if we take more extreme examples? So what if the speed of the river is equal to the speed of the boat in still water? So in this example, what would happen if the boat is moving at 25 kilometers per hour in still water, and the river is also flowing at 25 kilometers per hour? What would happen in that case? Try to see if what would be the average speed and how long will it take for the round trip and so on. Okay, that's it.